Hi guys, welcome to my second video on these electricity multiple choice questions. I have covered all the MCQs from June 2016 and specimen papers up to June 2018 in my previous video, so check it out if you haven't already. So we're going to start off with June 2019 paper 1, which is the AS paper, H156. So let's dive right in. So the first question is, which circuit below can be used to monitor the variation of light intensity? And we know that for light intensity we need LDR, and that happens to be option C. For question number 37, a household is planning to change all their 60 watts filament bulbs to 12 watts LEDs. The household has a total of 10 bulbs, and each bulb will be used for about 2,000 hours in 1 year. And the cost for 1 kilowatt hour of energy is 15.4p. What would be the annual saving? So we can work out the total cost with the use of 60 watt filament bulbs versus the total cost with 12 watts LED bulbs, and then consider the difference between the two. So have a go. If you want to try it, you can pause the video and let's otherwise just crack on with it. So for the 60 watts filament lamp, we know that the total cost is going to be equal to, we need to convert, we need to find out first of all the energy. Okay, so the energy transferred will be 60 watts. Now we need to divide this by 1,000 to get it into kilowatts, and so we times it by 10 because there are 10 bulbs, and for 2,000 hours we do not need to convert this into seconds or anything because the energy is measured in kilowatt hour. Okay, so the energy that it gives me is 1,200, and I will times that by 15.4p, and that will give me a value of £184.80. So that was for the 60 watts. Similarly, I can work it out for 12 watts. Okay, so the cost with 12 watts is going to be similarly 12 divided by 1,000, times it by 10, times it by 2,000, and I'm going to just also times it by 15.4p at the same time. So that would give me a value of 30. Well, I'm going to work this out. So that is okay, so that is 36, okay, 36 pounds and 96 pence, and therefore the difference between the two is going to be 147 pounds and 84 pence, so therefore C is my answer. So for this question we are given that the resistance of a wire of length L is 3 ohms, and it's now extended so that its length has become 1.5 L, and its volume remains constant. And what is the resistance of this extended wire? So because we are dealing with two variables over here, we are dealing with the length and the area, we need to consider the formula R equals rho L over A. Okay, now rho remains the same because it's the same wire. Okay, so we can just say that R is proportional to L over A. Now, in terms of the area, we know that if volume is equal to area times the length and V is constant, then A is inversely proportional to the length of the wire, okay, as V is constant. So this is, let's say, for our original length of L. So the new area is going to be, therefore, also proportional to 1 over 1.5 L, as that's the new extension. So I can just remove the proportionality because I'm going to take the ratios into consideration. So A is therefore simply put 2/3 L, like so. And sorry, that's the new A, okay, A dash. So now if I just say that the new R, which is R dash, is equal to similarly 1.5 L over A dash, okay, then 1.5 L over A dash, which is 2/3 of L, okay, will give me simply 1.5 times by 3, and L gets cancelled, over 2, so that is a constant, okay, so that will give me 4.5 over 2, okay, and that will just be 2.25. And now in comparison, therefore, to the original resistance, okay, which was 3 ohms, the new resistance will be 2.25 times the old. Okay, so that is going to give me a value of 6.75 ohms. So D is my answer. So let's move on to the next one now. We are given that in this diagram, the minimum resistance of the variable resistor is 0 and the maximum resistance is 3R. And furthermore, the power supply has an electromotive force of 4 volts and negligible internal resistance. The voltmeter has infinite resistance, so we know no current can pass through. And we are then asked to work out how does the voltmeter reading change if the resistance of the variable resistor is changed from minimum to maximum value. So since the resistance of the variable resistor is increased up to 3R, its value, the voltage across it, will also increase because V is proportional to R as I is constant in a series circuit. So it's a really simple question. If the resistance is 3 times the original, the voltage will go from 0, okay, as the resistance goes from 0 to 3 volts, okay, as the resistance becomes 3R. So B is the safe answer. Now, for question number 40, we are given that in a particle accelerator, the electrons are accelerated through a potential difference of 120 kilovolts, and the electron beam current is 8 microamps. Okay, so we need to work out the total energy transfer to the electrons in a time of 2 hours. It's a really simple question. We know that energy or work done is equal to voltage times the charge. Okay, and we are asked to work out the energy in 2 hours, and therefore we are going to find out what that is by timesing it by 2 hours times by 3600. So that is voltage of 120 times by 1000. The charge, okay, is basically current times time, and therefore 120 times 1000 times by 8 times 10 to the power of minus 6, and you times that by 2 times 3600, and there you have your answer of, okay, that gives me 6,912 joules, and therefore D is my answer to 2 significant figures. Now for the next question, the electric charge on particles is quantized and a multiple of an elementary charge. And now we know what that elementary charge is. It's 1.6 times 10 to the minus 19 coulombs. Which charge on a particle is possible? So it has to be a multiple of 1.6. Okay, so now if I try to multiply this by, let's say, a 2, okay, that will give me 3.2, so that can't be made into 4. If I times it by, let's say, 3, it will give me 4.8. Okay, again, doesn't work because 5 rounded to 5 is not an option. However, if I times this by a 5, it will give me 8.0. Okay, therefore C is my answer to this question. For question number 42, we are given that there is a part of an electrical circuit shown below, and the direction of all the currents and the magnitudes, of the 2 currents are shown. How many electrons pass through the point Y in 10 seconds? So this formula is quite simply I equals Q over T. Now Q can be written as NE over T, okay? Number of electrons times the charge on electrons. So if I can figure out what is the current at Y using Kirchhoff's first law, which suggests that all the current in to a junction is equal to out of the junction. Okay, so that means that 0.02 amps plus Y is equal to 0.06 amps. Okay, that's the outward current. So therefore Y becomes 0.04 amps. Okay, so now I can input that information into my formula above and rearrange. So N is equal to the current, which is 0.04, okay, times by the time, which is 10 seconds, divided by the charge on the electrons, which is 1.6 times 10 to the minus 19 coulombs, and that shall give me that gives me 2.5. Alright, so B is my answer. Now, so for question number 43, we are given a potential divider circuit, variable resistor R, with a potential difference of V across it, and we are asked to work out the correct variation with R of V. Now we know that the voltage is proportional to R, so as the resistance increases, V will also increase, so C and D are out, okay? However, when the resistance will increase, yes, the voltage increases. However, eventually the current will slow down, okay, because the resistance will cause the temperature to increase, and therefore the current will slow down and the voltage will also not increase as much as before. So it will be an exponential, rather exponential, it will be a curve increase, okay, so it would not be a B option, it would be therefore A, okay. With question number 44, we've got two wires P and Q made from the same metal, and they're connected in parallel across a cell of negligible internal resistance. And we are given a bunch of data for the two wires, and we need to work out the mean drift velocity in the wire Q. So because we are given the length and the diameter of the two wires along with the mean drift velocity of the original wire P, we need to put some equations, some relationships together. So first of all, we know that I equals NEVA, where V is the mean drift velocity and A is the area, N is the number of electrons, and E is the number of electrons per meter cube, and E is the charge on the electrons. Now, with respect to this particular question, because the number of electrons or the charge will obviously not change, the current will be proportional to velocity and the area, okay? Now, we are not given any information about the current, but we know that area of the cross-section is pi d squared over 4, okay? So we can work this out in a second, how we can relate the current with the resistance is also important because we are given the length and again area is concerned. So because it's parallel connection, we know that voltage will be constant and therefore current will be inversely proportional to the resistance. And the resistance in a wire is given to you by R equals rho L over A. And because they are same metal, rho is the same, so we can ignore that because it's constant. So resistance is therefore directly proportional to the length and inversely proportional to the area. Now, if we put all these relationships together, so I'm just going to write down that area is proportional to d squared, okay, for simplicity. Now, if we put the let's start with the resistance first, okay, because then we can put that into our current equation and then we can figure out what the mean drift velocity is. So with respect to the wire P, the resistance is going to be proportional to the length and the area, which is d squared, okay? And with wire Q, you're going to be having R proportional to 3L over 4d squared because you square the 2d, okay, so you get 4d squared. So if we now compare the two resistances, then the resistance of Q is basically 3/4 of resistance in P. Okay, we can quite clearly see that using these two equations. Okay, so we've established our first relationship. Now, similarly, if I is inversely proportional, then it is quite obvious that IQ is going to be 4/3 of IP, okay, because obviously you flip it as it's inversely proportional right here. Okay, so that's that. So now we've got pretty much everything, okay? We can now think about this particular relationship, okay? Now we know that in the initial wire, IP, the current is proportional to the drift velocity, which is 0.6, and the area is just d squared. Okay, and similarly in IQ, we know that it is, well, V, okay, times by 4d squared. Okay, so that's that. Now, if we are comparing this that we've just found, okay, we can safely say that because the current in the wire Q is 4/3 of the original wire P, okay, or the first wire, then we can say that 4/3, okay, is proportional, or rather, I'm just going to call it IP, okay, so we can just establish a relationship, okay, over IP is equal to V times 4d squared over 0.6 d squared. Okay, so I'm just putting these two equations together in terms of dividing the second equation by the first equation. Okay, so IP's cancel out, d squares cancel out, and therefore V is quite simply 4/3 times by 0.6 times by a quarter. In other words, it's 0.2 millimeters per second. So B is the answer. So now let's move on to the second question, 45, okay? And in question number 45, we are given that the sum of the currents entering a point in a circuit is equal to the sum of currents leaving the same point. Which quantity is conserved according to this law? So that's really straightforward. A is the answer, as current is proportional to charge, and therefore charge is conserved. In question number 46, we are given that the electron with an initial kinetic energy of 100 electron volts and initial speed of 5.9 times 10 to the 6 meters per second is accelerated through a potential difference of 250 volts. What is the final speed of this electron? Okay, so again, this kind of question has been asked a few times in multiple choice in the past papers before, and so remember this relationship, which is basically EV is equal to kinetic energy, okay, because the energy is conserved. So the work done on electrons is equal to the kinetic energy that they have as they are accelerated through a potential difference. So we are given the voltage, okay? I'm just going to leave E as the way it is, as I'll deal with it in a second. So E times 250 is equal to, now because there is initial kinetic energy and final kinetic energy, I'm going to just write it down as half mv squared minus, well, half, or rather just the initial kinetic energy, which is given to me. Okay, I'm just going to put it down as initial, just for explanation purposes. So now, if I rearrange it to make V the subject, I'll easily be able to figure out the velocity from there. Okay, so now this is 250 E, okay, plus the kinetic energy that we have been given, which is 100 E, okay, EV, I know, okay, that's just another unit of energy. So that times by 2 divided by the mass on the electrons, and then square root it. Okay, so that will give me V. And as for E, all I have to do is basically, I know that that's just the charge on an electron, so I just need to multiply it by its value, and so on and so forth. So if I put that in my calculator, let's see what I come up with. So, okay. Alright, so that ends up giving me an answer of 1.1 times 10 to the 7. So D is my value. Okay. For question number 47, we are given an electrical circuit with 3 resistors, and they're all made from the same material and have same diameter, which means that they have same area. Okay, and the mean drift velocity of the charge carriers in 100 ohms resistor is V. And what is the mean drift velocity of the charge carriers in 300 ohms resistor? Alright, so we know that as the resistance increases, the current will decrease, and so will the velocity. So it's going to be less than V. Okay, so that's out. Now, for the rest of them, we just got to think a little bit in terms of ratios rather than too many calculations. So we know that in here, we have a parallel connection. Okay, so the resistance is split up over here in terms of 2 to 3. Okay, so 2 to 3 ratio. And we know that current is inversely proportional to the resistance as voltage is constant. Okay, so the current is going to be, well, 1 over 2 to 1 over 3. In other words, it could be rearranged as 3 to 2. Okay, so that means that the current in the 300 ohm resistor is going to be 2/5 of what's there in the 100 ohm resistor. Okay, which therefore gives me an answer of A. Okay, 0.4 V. For question number 48, we are given two electrodes which are placed into a liquid, which is an electrolyte. And what is the correct direction of the conventional current, and what are the particles responsible for the current in electrolyte? So we know it's definitely ions, positive and negative ions. So A and C are out, okay? And we know that the current conventionally flows from positive towards the negative, okay? So it's to the right, and therefore D is our answer. In question number 49, it says which sequence shows the materials arranged in the order of increasing number density of charge carriers. So the conductors have the highest charge carriers, and then we have semiconductors and then insulators. So C would be the answer, as it's increasing in the number density of charge carriers. Now for question number 50, we are given a potential difference across a lamp which is 2.5 volts and the current is 20 milliamps. What is the energy dissipated in the lamp in the 3 hours? So we know that energy is equal to power times time, and because we are given voltage and current, it's just I times V times T, okay? And if I just put everything into my calculator in their right units, so 2.5 times by 0.02 times by 3 hours times 3600 seconds, so that would give me 540 joules, so D is my answer. Alrighty, so question number 51. Which one is not a source of electromotive force? Well, everything except the light-dependent resistor is a source, so my answer is B. Alright, for question number 52, we are given 4 electrical circuits and all resistors are identical. Each circuit is connected to the same power supply. Which circuit dissipates the least power? Okay, so dissipates the least power, meaning wastes the least power. So we need to know a couple of things. Number one, if you have, for example, they're all parallel except C. Okay, so let's just compare the idea between parallel and series. Okay, so if you have a parallel circuit, all right, so we know that P is equal to V squared over R. Okay, so that's basically, if voltage is constant in a parallel circuit, then P is indirectly proportional to R. So I know that not all of them are, well, all together in parallel, because these two are in series and then parallel to this one, and then these two are in parallel and then in series to this one, and these one all are in parallel. Okay, so what that means is that if you have a parallel circuit, we know that the overall resistance decreases, so the overall current increases. So more power will be wasted, okay, in a parallel circuit compared to a series circuit. So C will therefore be my answer. For question number 53, we are given a cylinder of conducting material which has a length of 6 times 10 to the minus 2 and a diameter of that, and a resistance of this. What is the resistivity? This is one of the easiest questions I've come across in this whole entire video. So resistivity, as we know, can be rearranged as R times A over L. Okay, pop in the values and you'll get the answer. So let's see what we get. So resistance is 24 times the area, which is pi d squared, and divided by 4, or you can just half it if you want to get in terms of the radius. And okay. So I end up getting 0.13. Alright, cool. A is the answer. For question number 54, we are given the number density in material X, which is 10 to the 28, I think it's meant to be meters to the minus 3, as it's meters per meter cube. And the other one has a charge density of 10 to the 5. So 10 to the 5 charge density is very low. Semiconductors have in the order of 10 to the 10. So that gives us A as our answer. Okay. For question number 55, we are given that a resistance wire is part of an electrical circuit, and we are to figure out which statement is correct if the resistance wire is pulled so that it becomes longer and thinner. Okay, so longer and thinner. We know that therefore the resistance of the wire will go up. Okay, so that means that first of all, the resistance of the wire does not decrease. Okay, the total resistance of the circuit remains constant. No, that's not going to happen because the resistance is increasing. So it's either between A and D. Okay, so the ammeter reading increases. Well, no, because the circuit is series circuit over here. Okay, so therefore D is our answer, and that kind of makes sense because the voltmeter reading will decrease as the resistance, well, if the voltage across here in the resistance wire would go up, okay, as does the resistance, then the voltmeter reading through the fixed resistor would automatically decrease because the sum of the voltage adds up to or is provided by the source. Okay, so if one decreases, the other one increases, and vice versa. Alright, so for question number 56, we are given a circuit with 4 light emitting diodes, P, Q, R, and S. 2 LEDs are lit in the circuit. Which one are these? So, if we think about LEDs, we need to know the correct way in which they should be put together in a circuit for them to work. And that is that, say you have one LED, okay, this is the positive side and this is the negative side. Okay, so that means if the current is flowing through, okay, like so, let's talk about Q first. The current will go right in and work normally, okay, and like so. Okay, so Q is definitely gonna be lit, okay, and then followed by, let's find out whether R is going to light up. Okay, so in fact, I mean, we know that if the current flows like so, okay, R is connected in the opposite polarity, so R is definitely not going to be the case. So that means C is out. Okay, and then let's figure out which one out of P or S will light up. So again, if you look at the direction, this is out as well. Okay, this is opposite polarity to the current, conventional current, and therefore D is our answer. Okay, so for question number 57, we are given a circuit with a thermistor. The resistance of the resistor is R, okay, and that of the thermistor is 2.5 R. The potential difference across the thermistor is 5 volts. Cool. What is the total PD across both components? Okay, so we know that if it is a series circuit, voltage is shared in proportion to the resistance as the current is constant. Okay, so if I just say that the voltage V1 over V2 is equal to R1 over R2. Okay, let's find out what is the voltage across the fixed resistor. I'm going to call it V1. Okay, and this is V2. So V1 equals 5 times R, okay, over the resistance of the thermistor, which is 2.5 R. Okay, and that gives us 2. And therefore the total, okay, mind you, total is going to be 7. Okie doke, let's move on to our next question. Okay, so in this question, we are given a battery of electromotive force, 6 volts, and negligible internal resistance, and we are further given that the current from the battery is 30 milliamps, the current in the resistor X is 10, so we know that among Y and Z, there's going to be 20 milliamps left. Okay, so what is the power dissipated in resistor Z? Okay, so we know that power can be figured out using I squared R, okay, and let's find out what is potentially, well, it will help if we know what the resistance value is. Okay, so resistance across X is, I can figure that out, okay, it is a total of 6 volts, okay, divided by the current that's flowing through X, which is 0.01, okay, so that is 600 ohms, okay, so that means that the resistance across Y and Z is going to be 6 over 0.02, which is going to give me 300 ohms, okay, so if I just figure out what is the power dissipated through X, I can then work out what is the power dissipated through Y and Z. Okay, so power across X is quite simply 0.01 squared times by 600. Now I can do it in many different ways. This is what comes naturally to me, so I'm using this formula, and it is going to give me a value of, well, 60 milliwatts. Okay, so now because there are two resistors, Y and Z, connected in series, okay, to one another, there's going to be twice the power dissipated, okay, and twice the power dissipated altogether, okay, so 120 milliwatts will be dissipated through both of them altogether. So individually, they will dissipate equal amount of power because the resistance is the same, as well as the current is 2. Okay, so B will be my answer. For question 59, it's asking us which term is not used in either of the Kirchhoff's two laws. So first law is all about current, okay, conserving the current and charge. And the second law is about, the second law is all about the sum of the electromotive forces is equal to the potential difference. Although charge is conserved, it's not directly talked about in the law. Okay, so A will be my best answer because current, EMF, potential difference, they're all mentioned in the two laws. Okay, so A will be my answer. Okay, so in question number 60, we are given a resistor of resistance 12 ohms is connected in parallel with another resistor of resistance R. The total resistance is 4 ohms, and what is the value of R? Okay, this is also one of the simple questions. We know the formula of 1 over R in parallel is 1 over R1, which is 12, plus 1 over R2, which is that. So this is the total over here, and we are given therefore 1 over R, which is what we're working out, is a quarter minus a 12th. Okay, and that is going to simply give me 2 12ths, okay, and therefore 6 will be my answer. Okay, for question number 61, we are given that a cell of electromotive force 1.2 volts is connected to a wire of resistance 6 ohms. The potential difference across the wire is 0.9 volts. What is the internal resistance R of the cell? Okay, so we know that EMF is equal to V plus IR, where R is the internal resistance. So if you just rearrange, this is a really straightforward question yet again. So 1.2 minus 0.9 over the current. Okay, so the current we can figure out is simply the voltage across the resistor divided by the resistance, which gives me a value of 0.15 amps. Okay, so that will be 0.15, and there you have your answer as 0.3 over 0. Okay, so that will give me C as my value, 2 ohms. For question number 62, we are given that there are 3.8 times 10 to the 7 electrons flowing through a wire in 1.2 microseconds, and we are to figure out the current. Okay, so I is equal to Q over T. And we know Q can be written as NE over T. So if we want to work out the current, we have everything. Okay, we have the number of electrons, the charge on the electrons, and the time. Just making sure everything is in the right unit and form. And let's find out what the final answer is. It's going to be a small value. Okay, so D is definitely not the answer. Okay, times 10 to the 7. Okay, so I end up getting C as my answer. Awesome. Right, for question number 63, which graph best represents the way in which resistance R of a negative temperature coefficient thermistor depends on its temperature in degrees Celsius? Well, that's a really straightforward answer, A. Okay, moving on to question number 64. We are asked to state which statement is correct for an IV characteristics of two components R and L. So R and L are both filament lamps. No, they are not, because R is a fixed resistor and L is a lamp. Okay, so that's out. R and L have the same resistance at 1.5 volts. Well, they do intersect, don't they? So if they both intersect at that point, they are going to have the same resistance, as the gradients will basically intersect as well. So B will be my answer. Alright, so question number 65. What is the total energy gained by n electrons traveling through a potential difference V? So again, E is equal to V times Q, or, well, in total, N times Q times V, okay? And that gives away D to be the answer. question number 66. So we are given a current that passes through an electrolyte and a resistor. We need to figure out charge carriers in the resistor. Well, they are electrons, okay? And the charge carriers in electrolyte are ions, so B is my answer. Okay, so this brings us right to our last question, number 67, where a potential divider circuit is given to us and the battery has an EMF of 9 volts and internal resistance is negligible. At the room temperature, the potential difference across the thermistor is 4.5 volts. Okay, so that is reading 4.5 volts, therefore this is also 4.5 volts. And the thermistor, now the temperature of the thermistor is increased so that its resistance decreases by 20% from its previous value. Okay, what is the potential difference across the thermistor now? So we can use the potential divider equation, which is V out equals R2 over R1 plus R2 times by VA. Okay, so we know that the resistance, I'm just going to call this R2 over here because that's what we're working out, and this is R1. So if the new resistance is basically decreasing by 20% of its original, we're going to have 0.8 of R2, okay, R2 being the original, okay, at room temperature. Now, let's put this in and see where we are at, okay, and obviously we'll have this R1 and R2 bits, which we will deal with in a second, and that's 9. Okay, so with respect to the two resistances R1 and R2, because the voltage is the same across the two at room temperature, and we know that the current also remains constant, then that means that the resistance is of the two resistors are equal. Okay, remember V equals IR. If V is equal, okay, then so will be the resistance. So R1 is equal to R2. So now from here, that makes it very easy for us. Okay, we can either substitute for R1 or R2. It will all cancel out. So 0.8 R2 over R2 plus 0.8 R2 times by 9. So that basically ends up giving me 0.8 R2 over 1.8 R2 times by 9. And obviously that cancels out, and that, let's see what will happen. So 7, okay. Alright, so that gives me a value of, very good, 4. Awesome. B will be my answer. Okay, now guys, if you were to guess, obviously, we certainly know that if the resistance is decreasing, so will the potential difference. So C and D would have been out. So I know you would have guessed A or B, and a lot of you might have said A as the answer. But for this is where you have to do some work. You have to do some calculations, and this is one of the examples of the calculations. Okay, so we are done with all the 67 questions that I have covered from all the past papers, ranging from the specimen to the June 2022 papers. Please let me know if you have any questions. What I did notice was the second half, which is this particular video, had some really, really good questions, and so it's worth you trying them at, by yourself and see how you get on. And you can always, look back at the video or the answers. The mark schemes are all on the OCR website, so do check them out. I will put a link to all these questions in the description box below. And yeah, thank you so much for watching.